This example shows how TPOT can be parallelized with Dask. So TPOT's an automated machine learning library. It does a bit of feature engineering and hyperparameter optimization for you. I'm not really familiar with the details, but from what I understand, it uses genetic algorithms to do the evaluation of which models are doing well and figuring out how to generate new hyperparameter combinations to try out in the next generation. So you'll see references to things like generations and mutation rates, things like that. Again, I'm not very familiar with the details, but from Dask's point of view, we're going to end up with a whole bunch of individual tasks that can be tried out in parallel. So in this example, we're going to be training on the digits data set, which is a small in-memory data set. It fits in memory on all of our workers. And we've attached to a cluster here with 40 workers with 2 cores each. So we've got 80 cores in total to work with. As a user of TPOT, the only differences that you'll see, the only changes you have to make to your code are you have to connect to your cluster here by creating this client and then specify this use Dask keyword. That's what will kick off this distributed training on your cluster. So this is an example of a CPU-bound problem. We've got a small data set and a whole bunch of different tasks to do on that small data set. So this works out quite well for Dask. On the left here, you'll see shortly all of the individuals in this first generation show up. So we're doing all this training, all this evaluation of these different scikit-learn pipelines on some CV split of the data in parallel. I'm going to flip over to the graph view here. It's not super useful. It shows it's kind of too busy to be really useful, but it seems like we're getting a bit of Dask ML's avoiding of repeated work here. Again, that's not super important, but it's a nice little bonus. The main takeaway here, though, is that we're getting these evaluation of individuals in parallel. That's working out quite well here. One thing that works less well, we'll see it here in a second, is we've basically finished this generation. We've trained all of the individuals in it, and right now the cluster is basically idle. That's because internal to TPOT, there's some code that's doing the determination of which hyperparameters and pipelines to try out next. That currently hasn't been parallelized with Dask, so that work's not going to be happening on your cluster. The second issue we've noticed is that this kind of straggler problem, so if you look at the bottom middle right now, there's 5 gradient boosted classifiers that haven't finished yet. And those 5 individuals are basically holding up our entire generation. We're not going to proceed until all of those have finished. This is a common problem in parallel machine learning. There are some proposals for how to deal with it. We haven't done any of that in TPOT. So right now it's just going to be identical to if you're using a single machine. You're going to wait for all of these individuals to finish, only it'll be happening faster since it'll be in parallel. And so that's overall things are looking pretty good. We've got some room for improvement with like this current period of idleness where the cluster is not being used, or with that straggler problem. But for the bulk of the runtime where you're evaluating all these individuals, that's being done in parallel quite well. Once this does finish, you end up with a regular TPOT classifier or regressor. It'll behave identically to how it would if you hadn't used a cluster to train it. So that's working out quite well. If you need to go ahead and apply that to larger data sets, you can use some of the wrappers provided by Dask ML to apply this prediction, classification, whatever, to a large data set, to a large Dask array or Dask data frame. Right, so the Dask ML and the TPOT docs both have more information on how to use TPOT and Dask together. So if you do have any questions, be sure to check those out.